Sandia National Laboratory is truly a national treasure when it comes to synthetic aperture radar. They've just done an enormous amount of great research and development in developing synthetic aperture radar techniques and pushing the limits of the technology. If you're interested, just go to Sandia Lab on the website. It's sandia.gov, I believe, and you can find a big section on their website where they just show you their systems and just a huge number of images, of which what I'm showing you is just a very, very, very small sample of. And I put these in first to say, boy, Sandia, you've done a great job in some of the stuff you've developed, and to give you examples of what SARs can do. I've just shown you here and there an image. Now here's a de Havilland twin otter that Sandia has, and right down at the bottom here is a 15 gigahertz synthetic aperture radar, and it collects data at ranges from 2 to 15 kilometers, and it processes these images in real time. And here we see a 1-foot image of the Pentagon. Now, you know, the Pentagon is a very, well, I think it's the world's biggest building in square footage, I believe. But it is a huge distance from here to here. The resolution is 1 foot. And here we see, there's the Pentagon, and here is this image is the whole Washington, D.C. area. Now just imagine how big a wall you'd need to see if that's the size of one image you can collect with this system. You know, it's just amazing. See the bridges crossing over into to Virginia, and you can make out the Capitol, you know, and all the different buildings along Washington there. And here, blown up, this is the KU band radar, and this is the U.S. Capitol building and the House office buildings, the Library of Congress, Supreme Court building, and this is the 1 meter resolution. Isn't that absolutely fantastic? Just leave it up there for a minute, because these are all the trees around it you can see, and the pools, and just fantastic. And here's the Capitol building all by itself to 1 meter resolution. And of course these dots are particular scatterers, high intensity scatterers in the image, and trees around the Capitol building. And I've only once been in the Capitol, and this is the House section, it's up on the 4th floor there. And then they go to the opposite. Sandia has developed a mini SAR. And these are just ordinary cables that connect in, you know, with BNC connectors or similar size. Here we see an array antenna. And this is the resolution is 16.8 gigahertz. The resolution with this SAR system is 4 inches. And at 10 kilometers, at 23 kilometers, it has a foot resolution. And it's just 60 watts of power. And you can either do SAR, spotlight, or strip map modes with this Sandia mini SAR. Here is a mini SAR image, the 4-inch resolution at 3 kilometers at Kirkland Air Force Base. You can see a DC-3. Let's see. Here's the DC-3. Make out the wings are a little hard to make out, but there are the 2 engines. Here's the tail. The helicopter here. Now the aircraft. That's 4-inch resolution at 3 kilometers. Here are the cars in the parking lot. See if we could find, you know, just unbelievable. And of course the roads. That's the kind of resolution we have in that smaller package. And they have a Lynx SAR radar, which is an antenna and a gimbal. And it's a spotlight SAR mode. And it has these parameters from 1/10 of a meter to 3 meters, depending on the range. And a strip map mode. It has a little bit poorer resolution, but it goes out to longer ranges. Really fantastic piece of work this Lynx radar is. And here's an image of using the Lynx radar of the Balin radar bridge over the Rio Grande. This is with 1-foot resolution. And you can easily see the tracks. Isn't that amazing? Now, at Lincoln Laboratory, I'm going to show you a couple of pictures. One real nice one. It's the LIMIT radar, the Lincoln Multi-Mission ISR testbed, the acronym LIMIT, in an ultra-wideband mode where it's got 2.5 by 2.5 inch resolution. And here's the phased array up front, and the nose is 50 centimeters. And this is a chunk of data that's 160 meter cutout from a 400 meter swath, just so you can see it up close and personal, by 260 meters out of a 2 kilometer swath. So, you know, just is to show you what 2.5 by 2.5 resolution image you can see. It's just absolutely remarkable. And that whole image, here we see these buildings up here, and down here, these buildings, and that building right there. I'll switch it off so you can see this area over here that the aerial photograph is covering up. It's just fantastic imagery. And I'm sure that the resolution that you see in your screen that you're looking at, 600 by 800 pixels, you know, crudes this up a lot. But the PDFs are better, but they're still not at all as good as these actual photographs. If you want to look at some of the really nice ones from Sandia, they're on their website. You can take a look at them. And also some images of LIMIT may be in Lincoln Lab Journal articles. I'm not sure if they're out there yet. And then we're going to go on to remote sensing, which will be our last lecture. And that will be the last part of this lecture, the next to the last lecture. And we'll start that in a little bit.